So for this lesson, you kind of already are familiar with this because I alluded to it when we were graphing logarithmic functions. But if you ever have an instance where you have something that's not very easy to figure out, 6 to what power is going to give me 4, it's not really clear. So what we can do is we can use the change of base formula, and we can take the log of 4 over the log of 6, changing them both to base 10, which allows us to use our calculator. And if I put that in my calculator and I say log 4 over log 6, I get the answer of 0.77. So log base 6 of 4 is about 0.77. In a similar way, if I have log base 1/3 of 8, I would just go ahead and put log of 8 divided by log of 1/3. And let's see what that would look like. Log of 8 divided by log of 1/3. And I get an answer of negative 1.89. So negative 1.89 for that answer. So let's go all out here with a word problem involving this type of thing. We have a function d equals this, and we have n1 and n2 are the numbers of each type of species. So let's say we find 25 and 50 for n1 and n2. So we would put 25 in for n1 and 50 into n2. So let's set this up here. If I can scroll down enough. So d equals negative uh, n1, which is 25 over what is the total number of species. So the sum of n1 and n2 would be 75, 25 plus 50, times log 2 of uh, n1 over s. So we have 25 over 75 plus n2 over s, so 50 over 75, times log 2 of 50 over 75. And this will tell us the measure of diversity in this environment. So first thing we want to do is go ahead and put in our change of base formula. So we want to make this log of 25/75 or log of 1/3 to make it simpler. Let's actually simplify all of these first while we're at it. So 1 over 3 times log 2 of 1 over 3 plus 2 over 3 times log 2 of 2 over 3. And go into my calculator uh, to get 1/3 times log base 2 of 1/3. I'm simply going to take log of 1/3 over log of 2. And for that expression, I get negative 0.528. And then I'm adding it to the second expression here. So 2/3 times log of 2/3 divided by log of 2. And we get negative 0.39 or 3, yeah, about negative 0.39. So when I add those together, we'll just add negative 0.528. I get negative 0.92. And since I'm not a biologist, I can't really tell you what that means, but it sounds like a good amount of diversity. Um, So let's go ahead and look at some examples for you to try. First, we have this log base 1/5 of 25. See if you can evaluate that. And finally, we have a word problem involving photography. So go ahead and read that and see if you can use the change of base formula. And otherwise, that concludes our lesson.